Okay, now guys, like I was saying in the other video, that the work done, hmm, is equals to what? Is change in kinetic energy. Okay, KE. And change in kinetic energy for a conservative field plus change in potential energy is equal to what? Zero. So that means that the change in kinetic energy, KE, is equal to what? Minus change in what? Potential energy, PE. So this is work done. So work done is what? Minus what? Change in what? Potential energy. This is the work done minus change in potential energy as the work done. So this is the equation for work done. Now let us use this formula to know whether we can find the formula for what? The potential energy. Okay, remember in this case potential energy will now be equals to the negative of what? Of the work done. Do you understand? Negative of the work done. So now remember, this is change in potential energy. Okay, change in potential energy. Now work done is equal to what? Force times what? Distance. Okay. So now let us have a gravitational field. Now this is the Earth. Now this is the orbit. This is an orbit. This is the radius of the orbit. Okay. This is the radius of the orbit. So work is being done here. Okay. So now if you take a particle from the center of the Earth to this orbit, a work is being done, and this is the distance that is being what? Covered. Okay. So in that sense, the force will become the force of attraction between the center of the Earth and the center of the particle, which is the gravitational force. So the work done is equal to what? G mm over what? Over r squared times r. In this case, the distance will be what? R. Okay, so we now have that work done is equal to G mm all over R. Okay, work done is equals to G mm over R. Remember, change in potential energy is equals to negative of what? The work done. Do you understand? So therefore, we now have that since we have gotten the work done, okay, in taking a mass from here to here. Okay, so the negative of the work done is now equal to, that is change in potential energy, is equal to what? Minus G mm over R. You see? So this is it. So this is it. So change in potential energy is equal to what? The work done, negative of the work done. Do you understand? By the gravitational force in a conservative field. Do you understand? Like the gravitational field. So this is the formula. Change in potential energy being equals to minus GMM over R. Okay. So now I think we need to verify this thing, that change in potential energy is equals to minus GMM over R from the definition of gravitational potential energy, that is, which is the work done in taking a mass from infinity to to any point in the gravitational field. So in my next video, I will explain this thing again well.